Section 2.3 has two goals, product rule and quotient rule. We're going to focus this time on product rule. When do I need it? Why do I need it? Product rule. Product rule happens, we've been saying all along that you get one, or you must take a single derivative per term in a problem. I'm saying that with x squared minus 3x. You get to take one derivative per term. Well, here we are. The problem is now the term, the single term, has gotten a lot more complex. And it's made up this time of a red function, f of x, being multiplied by a blue function, g of x. To make things really, really easy, for every piece that's being multiplied together in your individual term, you're going to create a term in your derivative. I'm going to make this a little bit, zoom it in a little bit so I can see it better, or so you can see it a little bit better. So there's two things being multiplied, which means there's two terms in my derivative. How do I figure it out? Well, basically what you're going to do is you're going to look at it and you're going to take inventory. I see two things being multiplied. Okay, so pick one of them, f of x. What's its derivative? Its derivative would be f prime of x. Okay, and then I'm going to take this thing, I'm going to multiply that by the rest of the original. Well, what's in the rest of the original? The rest of the original is g of x. Okay, now move to the second term. In the second term, pick part of the function. Oh, g of x. What's its derivative? G prime of x. Multiply that by the rest of the original. And then when you look at what we've just done, basically we took the first function and multiplied it by the derivative of the second, and we took the second function and multiplied it by the derivative of the first. Does the order matter? Nope, because you got an addition in between. The important thing is two things being multiplied together means two terms. In one term I take the derivative of one piece, in the other term I take the derivative of the other piece. It's actually pretty easy to work with. And if we move down here and we look at a couple of examples, so number one, number two, notice number one is all algebraic. Number two has got some algebra and some trig to it. Let's do number two first. So problem number two, again, single term made up of a red function being multiplied by a blue function. And that's going to be one of the hard things for people to get used to is, what exactly do I have? Take inventory of that problem. So when I go to take this derivative, there's two things being multiplied. There's going to be two things in my derivative. In the first part, let's see. Let's pick a function. Let's pick x. What's x's derivative? X's derivative is 1. I'm going to multiply that by the rest of the original. What's the rest of the original? There's going to be multiplied by that sine of x. Okay, now pick the other function, sine of x. What's sine of x's derivative? It's cosine of x. We'll multiply that by the rest of the original. What's the rest of the original? Oh, there's an x. So again, taking inventory as we get done with this thing. In one term, I took the derivative of the red function. In the other term, I took the derivative of the blue function, and I effectively multiplied each of those individual pieces by the rest of the original. So in one term I have a derivative of sine, which is cosine, times the x that was part of the original. In the other term I have the 1, that was the derivative of the x, times the sine of x, that was the rest of the original. And there's not a whole lot of cleaning up here. I guess that we just sine of x plus x cosine of x, and we'd be ready to go. Problem number one, the reason I skipped this one is I'm hoping that as people look at it and go, oh, I see a red function and I see a blue function, so I should use product rule to multiply those two things together. You're right, you definitely could do it that way. And I'm going to write out those steps just to kind of give you something to think about. So here's my steps. So f prime of x is going to have two terms in it because there's two things being multiplied. So how do I figure out those two terms? Let's pick the red function. The red function, let's take its derivative. So that would be a 3 minus a 4x, and I would multiply that by the rest of the original. Well, the rest of the original, I'm sorry, I'm having all kinds of trouble. The rest of the original would be the blue function, 5 plus 4x squared, plus, okay, so now let's look at the other part of the function. The other part of the function is an 8, or the derivative of the blue function would be an 8x, and I'd multiply that by the rest of the original. The rest of the original would be the red function, 3x minus 2x squared. Well, if you look at what we have now, we're going to now have to multiply out that binomial. We're going to have to distribute that ax and put all my like terms together. So this derivative is going to get to be a little bit, the derivative part wasn't that bad. I followed the product rule. But the algebra is going to be a pain in my butt. The alternative to this would be, what if we tried this instead? What if we took the original function and we multiplied out, we did a little algebra, 15x plus 12x cubed minus 10x squared minus 8x to the fourth. Okay, so there I took care of the algebra. And then we took the derivative of each of those individual terms because now I see 4 terms. So let's do 4 derivatives. First term's derivative is 15 plus 36x squared minus 20x minus 32x cubed. There's the derivative. And if you would have carried out this algebra over here on this side, it would have taken you to the exact same place. So my advice would be, with a problem like number 1, do the algebra ahead of time and then take the derivative. Because if you do the derivative first, what actually happened to us is we doubled the amount of algebra we would have needed to do. Problem number 2, you can't avoid the product rule. You have to do it. No way around it.